Ну а сейчас я передаю слово следующему докладчику, удаленно выступающему. Это Синтия Чанг из Канады, президент и соучредитель Rising Tide Foundation, писатель фонда стратегической культуры и бакалавр в области молекулярной генетики. Доклад Синтии Чанг продолжит панельную дискуссию «Хозяйственная деятельность человечества и экосистема Земли. Поиск баланса для счастливого будущего». И он называется «Озеленение пустынь, ликвидация свалок и конец ограниченным ресурсам. Города будущего через 100 лет». Попрошу включить докладчика.
Hi, can you hear me? Hi, can you hear me?
Yes, we can.
Is it a, and, oh, okay, and the slides are also shown, perfect. Greetings, everyone. I'm very happy to speak today on the subject of cities of the future 100 years from now. Of course, this is a very exciting prospect, and there are countless possibilities for how cities can be organized in the future in terms of transportation, residential housing, city centers, and so forth. However, what I would like to focus on in this class is what is fundamentally needed as a foundation before we can embark on building such exciting projects in the future. This foundational backbone of any future city will require a means for producing its own clean water and adequate amounts of food. It will require sufficient energy production to power these needs, which is reliable and sustainable, and will require a means in changing its present relationship to how we use and dispose of our resources, such that the process must become much more efficient than it presently is, and it must produce much less waste. Such cities of the future will be comprised of large populations, and we will require a completely new system of physical economy in order to address those needs. If we remain on the current trend of today, we will never accomplish the cities of the future, for we will not have the population size nor the high energy yield required to produce such things. So let us begin our journey. First off, the question of greening deserts. The greening of deserts will address shortages of water and food and will make lands that are presently inhabitable, not just for bare survival, but with a high standard of living. Presently, there is over 16 million square kilometers in area that makes up the world desert. About 2/3 of the world is desert, with the Sahara making up 9.2 million of the 16 million square kilometer. Not only is 2/3 of the world desert, but grassland regions are presently experiencing desertification and is a major cause in water and food shortage. In addition, there's a lack of clean water leading to further sickness and disease. Sandstorms can also cause a lot of damage to city centers, costing up to millions of dollars in repairs, money that could be much better spent elsewhere. Transportation resources are also greatly slowed down by this. And sandstorms can cause serious prolonged periods of air pollution in cities, which cause numerous deaths a year. The above picture is of Sydney, Australia. Lastly, large regions of desert area can cause the formation of extreme storms. The Sahara Desert, for example, can cause hurricanes to hit the eastern coast of North America due to the abrupt temperature change from air currents heated passing over the Sahara to rapid cooling once over the Atlantic Ocean. In areas where extreme desert has already formed, the challenge is great. However, there has already been significant progress in this. Palm trees are very good for greening desert regions. They provide shade, they work as windshield, and can stabilize the soil. They also provide food. The shade provided can allow for other crops that are less heat resistant to grow more efficaciously. Egypt has managed to plant trees in the desert using wastewater. The Serapian forest, which has boomed despite the drought and rainfall deficit, consists of 200 acres of trees planted in Ismailia city in northeast Egypt and has set a precedent for other African countries. China has also had immense success in greening its deserts with robust tree planting and have succeeded in changing desert ecosystems to sustain green life over the long term. However, all of these projects, which have been applied with great effect, also require a lot of water. Thus, the question is, where will the water come from? Well, there are several options, all of which need to be assessed in terms of the best plan for a specific region, including cost. Water direction projects to replenish already existing water systems that have dried up are one option. The Trans-Aqua Canal is an example of this. It would take water from the Congo River system and redirect it to Lake Chad, which would then be able to support growth that could eventually help to further green the Sahel and the Sahara Desert. Although the majority of water redirection proposals are nothing new, the majority of these plans have yet to be realized. A major reason for this is that our present technology capabilities have lagged behind our production and development needs. I will speak more on this shortly. Thus, projects like these are extremely costly, time-consuming, and require a lot of materials that many countries do not produce presently in adequate amounts. Again, the Lake Chad replenishment project would divert approximately 5% of the water runoff from the Congo River Basin to refill Lake Chad. It may seem like a lot of work for these water diversion projects, but the payoff is also great. In the case of the Lake Chad replenishment project, when it will be done, massive amounts of hydroelectric energy will also be available, making it very cheap. It will also serve as a very important role in flood control that can save crops and provide stable ground for industrial development. Another exciting prospect for the future is weather control through the controlled ionization of the river systems in the sky. Atmospheric ionization systems have been successfully used to increase precipitation and affect associated weather processes. This has been done in multiple locations around the world already for a total of 3 decades. With further development of these technologies, droughts around the world could be overcome in a completely new way by the management of the water resources of the sky. It has been reported in multiple studies that periods of low solar activity and high galactic influence, such as cosmic rays, affect the amount of rainfall and also the amount of glaciation formation. According to scientist Sergei Poulinets, who has over 35 years experience in space plasma physics and currently works at the Russian Space Research Institute, clouds which cover our planet to a great extent are formed due to galactic cosmic rays, which produce ionization. These ions then become the centers of water vapor condensation and nucleation and formation of drops in clouds, which we see every day. There is a correlation thus between cloud coverage of our planet and the variations of the fluxes of galactic cosmic rays. This has been confirmed by numerous studies, most notably that of Heinrich Svensmark, a Danish scientist who found that there was 95% correlation between cosmic ray intensity and cloud formation from decades of observation. When we are in different galactic environments, we see changes in our climate system. We also experience temperature change depending on whether we are moving above or below the galactic plane as pictured above. Thus, through observations of many studies, we are finding that galactic processes dictate how climate and weather are expressed on Earth. A study by Perez and Perezza found that modulation of fluxes of galactic cosmic rays could also be the cause of Earth's periods of ice ages, and that it could be connected with movement of our solar system within the arms of our spiral galaxy as depicted in the below picture. They hypothesized that when the solar system is inside the arms, there is more dust, so there is less flux of the galactic cosmic rays, and between the arms, we have larger fluxes of the galactic cosmic rays. These periods coincide temporally with periods of increased and decreased temperature of our planet. Sergei Poulenets ended up working with a Mexican company named ILAT, which made experiments that stimulated rainfall. They had contracts with governments of different states, especially in the drought areas of Mexico, such as the Sonora Desert, to produce rain to increase the harvest in these areas. This idea was first proposed by Russian scientist Lev Pokmelnik, who is the founder of the ILAT company. They were able to produce rainfall by using an iron mast, as seen in the picture to the right, connected by thin wires to peripheral towers. If, for example, you put a positive potential on this installation, the positive ions will be moved by the electric field up to the upper layers, and moving to the upper layers, they gain more and more water molecules and become nuclei to form clouds. If you put your installation near the seashore, you can collect the humidity and then transport it. Because you can put different potentials, one positive, the other negative, between two installations. This creates movement of the air, which is filled by these nuclei for the formation of clouds inland. This thus helps to move air filled with humidity inland for cloud formation and rainfall further inland. Poulenets has had impressive results using this process and was able to fill 3 dams in Mexico using this technology after 1.5 years. They were even able to fight off forest fires in the Yucatan Peninsula, creating artificial rain using this technology, which yielded about 20 to 30% increase in precipitation. Poulenets has also remarked that many physicists today who study the atmosphere think only in terms of hydrodynamics. For example, describing typhoons, hurricanes, they look only at the hydrodynamic mechanical movement, but they forget that we are living in an electrical world. There is a huge electrical potential on the top of a hurricane. We live in the constant electric field which exists between the ionosphere and the ground. The potential difference between the ionosphere and the ground is near 250 kilovolts, and sometimes it can gain 400 to 500 kilovolts. And on the ground surface, the vertical gradient of the electric field is 100 or 150 volts per meter. If you are a tall person, between your feet and your head, you could have a 200 volt potential difference all the time. This potential difference is created by thunderstorm activity globally. Thunderstorms charge the ionosphere positively in relation to the Earth, and we have a closed electric circuit called a global electric circuit. The picture here looks like something from a sci-fi science fiction movie, but in fact is a rather natural occurrence. The phenomenon is called sprites or red sprites, which are large-scale electric discharges that occur high above thunderstorm clouds, giving rise to a quite varied range of visual shapes flickering in the night sky. They are usually triggered by the discharges of positive lightning between an underlying thundercloud and the ground. Sprites appear as luminous reddish-orange flashes. They often occur in clusters above the troposphere at an altitude range of 50 to 90 kilometers. Thus, as Poulenets makes the point, their ionization technology that he uses is given to us already by nature, and the technology of ionization is only helping a little bit with something that would already naturally occur, creating additional centers of nucleation. Simply put, you form nuclei near the ground surface and then transport them up with an electric field. This will create nucleation centers that will form into clouds. This can occur in any level of relative humidity. Of course, the higher the humidity, the more effective the process. We have found through studies that the sun, as well as high energy radiation, known as cosmic rays from the galaxy, are actually inputting constantly input that shapes the environment of the atmosphere, affecting climate, weather, and how water moves through the water cycle. Thus, Poulenets' ionization technology is actually acting in a very similar fashion to the ionizing effects of the galaxy. That is both the sun and galactic cosmic rays which have much higher energy, are the only known sources of ionization, and the altitude of penetration of these particles into the atmosphere depends on the energy of the particles. Solar particles have lower energy, so they don't actually penetrate to the lower levels of the atmosphere, and they lose their energy at those altitudes. This is a source of the northern lights. They're able to excite molecules, atoms, such as oxygen and nitrogen, which cause the green and red polar lights. As we gain a better understanding of our galactic processes, we will also gain further understanding and control on how to control weather formation. In the future, this will likely be the cheapest and easiest way to green deserts. As a quick note as well, CO2 generators are already a current form of technology in use today to grow vegetation in greenhouses and show much promise in their use for space travel. They can pump up to 1,500 parts per million of carbon dioxide, and the average carbon dioxide on Earth's atmosphere that naturally occurs is 400 parts per million. CO2 generators offer a lot of promise in producing yield in typically inhabitable regions such as Antarctica, or in space such as on the Moon or Mars. Next, I'll quickly discuss turning landfills into resource mines. The next domain in the future in industry will be to completely revolutionize our relationship to resources and waste, and is located in low and high temperature plasma processes, which will dramatically increase the productivity of steel, iron, titanium, and any other metal resources needed for a modern society. The plasma torch is already a technology we have today. It functions by injecting gas into the chamber, the electric discharge traveling from the negatively charged cathode on the left to the positively charged anode on the right, heats up with the resistance from the gas to such a high temperature that ionization occurs, which can reach temperatures of 15,000 degrees Celsius, which can reduce any material to its elemental components. The next step is a more powerful and efficient plasma processing, which will be through fusion plasma torches, which will open up a new realm of possibilities in the degree of precision in which we can transform energy and matter. Contents put into the fusion torch are shock vaporized and become part of the plasma as separate ionized elements and electrons. Once in a plasma state, various methods can be used to select the desired elements and isotopes based on their atomic as opposed to their chemical properties, allowing for the formation of very specific chemical compounds, creating batches of very pure chemical structures tailored down to the isotopic level. This will allow for the formation of more advanced materials than we currently can produce, and which are presently impossible to create with our present lower energy yield technology. Thus, with plasma torch technology, the pure elements can either be safely released into their environment, as in the case of nitrogen or oxygen, or they can be totally recycled, as in industrial raw materials. There will be absolutely no pollution. The plasma torch technology has been commercialized. Not the fusion plasma torch, but just the plasma torch technology has been commercialized for decades, but it is not in widespread use today due to its large use in electricity, which makes it currently very expensive. Only military bases and some specialized industries use it presently. However, with fusion technology, electricity for nations will become the cheapest it has ever been, making it economically viable for all industrial waste, industrial pollution, landfills, and garbage islands in the ocean to be recycled into resources that can be used once again for commercial and industrial needs. There's some controversy over when, if ever, we will achieve nuclear fusion. But as Professor Leonov has discussed, and I'm sure Dr. Tenenbaum has also addressed this question adequately in his lecture to you. Suffice to say that plasma torch technology will not only get rid of all landfills in a clean and sustainable manner, but it also means that there will be no such thing as waste anymore, since everything we use can be used over and over again as a resource with no end. Even the material of old, out-of-date infrastructure can now be reused, once broken down to its elemental components, to supply improved material for new infrastructure. Wood burning and fossil fuels will no longer be needed. Water canals, nuclear plants, high-speed rail all need a lot of steel, much higher than what is our current capacity to produce worldwide. In a fusion economy, there will no longer be such a thing as limited resources, and zero-sum artificial restrictions will cease to exist. There will be enough not only to support a growing population on Earth, but to support populations that in the future will inhabit the surface of the Moon and Mars and beyond. Fusion will also produce the rockets we require in order to travel back and forth to Mars in a timely fashion, much more timely than we are capable today. In a fusion economy, the future will look towards the existence of yet to be created potential. The greatest good for the greatest possible number will become a reality. Resource wars and economic competition over limited resources will no longer be, and cooperation towards universally beneficial projects, not only cross-continental, but interplanetary, will become the new norm. There will be no limits to growth, and thus no limits to the prosperity that can be achieved by humankind in the future cities of the world. So what are we waiting for? Let us begin our cities of the future today. Thank you.
Thank you very much. We have time for a couple of questions. Есть время для парочки вопросов, если у кого-то есть.
Yes.
Здравствуйте. Как озеленение повлияет на животный мир пустынь?
What do you mean by that question? I would just note that it's normal for the climate of the earth to change and for greening processes to occur. Actually, what we see right now with the increased CO2 in the atmosphere, as has been observed in the Sahel region, for instance, which is right below the Sahara desert, there is natural greening that is already occurring in what was previously desert regions. So this is already the trend that our Earth is entering into. And by us helping to facilitate that process, it will greatly increase the diversity of life, and it will also greatly increase the standard of living of people living in these regions.
Еще вопрос. Да. Только микрофон возьмите, пожалуйста.
Вопрос, наверное, был в том, что в пустынях есть своя жизнь, своя экологическая система, сложилась экологическая система. И если мы будем менять пустыни на зеленые леса, насаждения, не приведет ли это к тому, что исчезнут какие-то биологические виды, которые проживают именно в пустынных населениях, да? Вот в чем вопрос-то был.
As I already addressed, though, there is already a natural trend to, by the Earth itself, with the increased CO2 in the atmosphere, to greenify these regions. And I would also note that a desert doesn't just stay in a stable situation. it will also increase. So right now, what we are seeing is an increase in desertification. And this also affects life, diversity of life in those regions that were previously green that are now being desertified. So I would say that you would have actually more life, more diversity with this greening effect, which is natural, which is already what the earth is entering into. Australia has also seen marked increase in greening because of merely CO2 in the atmosphere. As we've seen with the effect of CO2 generators, CO2 is very effective at this.
Еще один вопрос. Вы назвали свой доклад «Города будущего через 100 лет». Есть ли какие-то примеры городов, которые планируют хотя бы на 30 лет, к 2050 году, в соответствии с планами по Парижскому соглашению? И если есть, то какие города бы вы назвали в качестве лидеров, у кого лучше всего такие планы?
I wouldn't know the details for a question like that, but what I have seen from what China has been doing, it has been addressing a lot of these standards. And again, nuclear fusion, which I believe we're not very far from, and I think a lot of speakers at this forum also believe in this. Nuclear fusion is by far the cleanest energy we possibly could attain that we know of. So there's no waste, there's no emissions, nothing. So it's in our best interest that we can accomplish nuclear fusion in a timely fashion for several reasons, and one of them being that it would be very good for the environment. And I believe China is making very big breakthroughs in this field.
Спасибо большое вам за выступление и за ответы. Спасибо.
Thank you.
Давайте поблагодарим докладчицу.